In today's lecture, I'd like to talk about determining the correct size for your illustration and also talk about the concept of resolution. In Photoshop, when you create a new file from the File menu, you'll always see this dialog box, which asks you to enter the height and width of the image in inches or centimeters or some other units of measurement. It also asks for the resolution of the image, typically in pixels per inch, as well as the color mode. Illustration could be a bitmap illustration, which consists of just pure black and pure white pixels. An illustration could be grayscale, meaning it consists of many shades of gray, or it could be one of the color formats such as RGB, CMYK, or lab color. We'll come back and talk a lot more about color mode at some time in the future. Today I want to just focus on width and height and resolution. Whenever you create any kind of raster image, you need to specify these different parameters: the height and width in some unit of measurement and the resolution in pixels per inch. This applies to any raster image, not just those that are created in Photoshop. So for example, when you scan a document, you are also creating a raster image. All scanned images are raster images. This is the scanning software that I happen to have on my computer. And if you look over on the right side of the screen, you'll see that the scanning software asks me for the color mode. So again, we have options like black and white, which is the same as bitmap, grayscale, or color. And we're also asked for the image resolution. This particular software uses the abbreviation DPI, which is short for dots per inch. That's actually a misuse of the term. When you're creating a raster image, the resolution should be expressed in pixels per inch, the number of pixels in a linear inch. DPI actually refers to something else, but unfortunately, the terms have become interchangeable, and many programs, including this one, actually misuse the term DPI. And down here you can see how the software is also asking for the physical dimensions of the image. And there are some preset options that you can choose from here. So I could scan something at business card size, typical photo size, like a 4x6 photo, letter or legal size, standard US paper sizes, as well as a variety of different pixel dimension options. In addition to raster images created in Photoshop, as well as scanned images, which are raster images, even digital photos are also raster images. You can also generate raster images from a vector program like Illustrator. Now you may recall that Adobe Illustrator is a vector program, meaning that all objects in Illustrator are created using anchor points and mathematically defined paths. There are no pixels in Illustrator. Illustrator does not use pixels to construct the image. It uses those mathematically defined vectors instead. So the whole concept of resolution is irrelevant in Illustrator. However, within Illustrator, you can export a raster image. Under the File menu in Illustrator, you can choose the Export command and export the artwork in a variety of different raster images: PNG, BMP, JPEG, PSD, TIFF. These are all raster image formats. Let me choose the Photoshop PSD format and click Export. And you'll see that Illustrator asks us for a lot of that same information. It asks for the color mode. We have the options of grayscale or two different color options. And we have the option of setting the resolution. And you can see that Illustrator correctly uses the abbreviation PPI for pixels per inch. Now, Illustrator doesn't ask us to specify the physical dimensions, the height and width. Illustrator uses the height and width of the artwork itself to determine the height or width of the exported raster image, but you still have to specify how many pixels are going to be generated when it's converted from vector art into raster art. So going back into Photoshop, we come back to these settings here of selecting the height and width of the image and the resolution. Let's talk a little bit about selecting the physical dimensions of the image. Now, sometimes it's very easy to determine what the correct height and width should be. Oftentimes, your client will give you that information. They will tell you that they're creating an image for the web that needs to be a certain size, or they may be creating the cover for a magazine or a book, and they can give you the exact dimensions of that cover. And so you get the information directly from your client. In other cases, though, the client doesn't provide you with the exact dimensions, but you still may need to know what those dimensions should be, depending on the type of medium that's being used to reproduce the image. Fortunately, Photoshop comes with a number of presets that let you automatically choose the correct size for different types of media. So, for example, there's a set of presets for the standard US paper sizes. You can see here the standard letter size, 8.5 by 11, legal size, 8.5 by 14, and tabloid size is 11 by 17 inches. There are also presets for international paper sizes. The US is the only country that uses the standard letter, legal, and tabloid sizes. Most other countries use these kinds of standard sizes. A4 is the closest to the standard US letter size. You can see that the dimensions are specified in millimeters, but if we were to change the units to inches, you'll see that it's a little bit smaller than 8.5 inches in width, but somewhat taller than 11 inches in height. So it's close to 8.5 by 11, but not quite. And then there are a number of other standard international sizes. There are also some standard presets for common sizes for photographs. You can see that these can either be in landscape mode or portrait mode. Landscape simply meaning that it's wider than it is tall. Portrait being the opposite, where it's taller than it is wide. And you see there are standard sizes like 4 by 6, 5 by 7, 8 by 10. There are also presets for creating different size images for the web. Now really, you can create an image for the web at any size you want, but these are standard dimensions that are based on the size of people's monitors. There are similar presets for mobile devices, such as cell phones, iPhones, iPads, and so on. Notice that these are all expressed as a certain number of pixels in width and a certain height in pixels. So they're not giving actual measurements in inches or centimeters, simply a total number of pixels across and a total number of pixels in height. There are settings for different film and video standards. For example, in North America, television broadcasts conform to the NTSC standard, whereas in Europe, they use something called the PAL standard. So somewhat different size and settings for TV broadcasts on the different continents. There are also high-definition TV standards, such as 720p and 1080p, and even settings for different motion picture formats. In addition to the presets that come preloaded in Photoshop, there may be other standard sizes that you should be aware of. For example, as medical illustrators, there's a very good chance that somebody will ask you to create images for PowerPoint. Faculty in medical schools use PowerPoint for their teaching. Researchers will give PowerPoint presentations at conferences. And so there's a lot of demand for creating images to be placed into PowerPoint presentations. PowerPoint uses a standard size of 10 inches in width and 7.5 inches in height. So you could choose a custom setting of 10 inches in width and 7.5 inches in height. That's the standard size for a PowerPoint slide. So let's talk now about the concept of resolution. You know that raster images are composed of small picture elements known as pixels. When you create a raster image, the entire image has to be divided up into this grid of pixels. I like to think of it as a parking lot. When you create a parking lot, first you pave the parking lot, but in order for cars to know where to park, you have to paint lines on the parking lot. That designates the parking spaces. So when you create a raster image, you're dividing the image up into a grid of individual pixels. And those are the elements that you can actually change to change the color of different parts of the image, or to draw objects. You're simply changing the color of the pixels. So Photoshop has to know where those pixels are before you can actually start painting. Just like you have to paint the lines on the parking lot so the cars know where to park. So let's go ahead and click OK here to create an image. And it starts off as just a blank screen, and you might think that there's nothing here yet. But in fact, this entire image is already subdivided into individual pixels. If I were to zoom in on this, you really couldn't see the individual pixels because it would still appear to be just white. But if I were to take a paintbrush and paint something, zoomed out, this appears to be a fairly smooth line. It may be a little bit fuzzy. But if I zoom in on it, now you can see the individual pixels that make up the image. And if I zoom in even more, I could take my pencil tool, for example, and actually modify individual pixels one at a time. Now, when I say that this image has a resolution of 300 pixels per inch, that means that if we were to look at one single square inch, that square inch would be 300 pixels across, 300 pixels in width, and also 300 pixels tall. So there would be 300 pixels in a linear inch in the vertical dimension, and 300 pixels in a linear inch in a horizontal dimension. That means that a single square inch actually contains 90,000 pixels. 300 wide by 300 tall gives you a total of 90,000 pixels. So every square inch in this particular image contains 90,000 individual pixels. Some people get confused by that, and they think when we say 300 pixels per inch that that means a total of 300 pixels within a square inch, but that's not the case. It's 300 pixels across in a linear direction times 300 pixels vertically in the vertical dimension for a total of 90,000 pixels within that square inch. 300 pixels per inch is considered relatively high resolution, meaning that the individual pixels are very, very small. A given inch is subdivided into lots of small individual picture elements. That means that the individual pixels are so small that if we were to zoom out to 100% size, the individual pixels are not visible to the naked eye. Now I could create a different image at a lower resolution. Let's create the same 8.5 by 11 image at 72 pixels per inch. And let's draw something with our brush tool at this size. And at this magnification, I still can't see the individual pixels, but I don't have to zoom in very far before they start to become evident. So this image is only divided into 72 pixels across in a linear inch and 72 pixels down in a linear inch in the vertical dimension. When you create a new image in Photoshop, or when you go to scan an image, or export a raster image out of Illustrator, anytime you create a raster image, you have to choose the correct resolution setting. How do you know which resolution to choose when you're starting on a project? If you are creating an image that will be viewed exclusively on a computer screen, the answer is actually quite simple. The typical computer monitor or computer screen can only display 72 pixels per inch. Therefore, you can create your artwork at that same resolution, 72 pixels per inch. If you created something at higher resolution, that additional resolution, those additional pixels, would simply be wasted. It would create a bigger file, but the computer couldn't display any more than just 72 pixels per inch. So if you are creating an image that is going to be viewed on a web page, viewed in a PowerPoint presentation, viewed within a Flash animation, or any other medium that's going to be viewed exclusively on a computer screen, then 72 pixels per inch is the appropriate resolution to choose. The situation becomes quite a bit more complicated when we talk about creating images for printed media. In general, printing something requires quite a bit more resolution than simply displaying the image on screen. In order to understand exactly which resolution to use when creating an image for print output, we have to talk about the concept of a halftone. A halftone is the way that a printed image simulates the appearance of a continuous range of values, a continuous range of gray values. It turns out that printers cannot print gray. They cannot print intermediate values of ink. A printer can only print solid ink, or it can leave the paper completely blank. It can't print a shade of gray. This is true of an inkjet printer, a laser printer. It's true of a printing press. Every kind of printing technology is the same in the sense that they can only print solid ink or solid toner on paper, or they can leave the paper just blank white. They can't print intermediate shades of gray. So how is it that a printer is able to print something that appears to have shades of gray? The printer does this by generating something called a halftone, like you see here. So here's a picture of an animal that to the naked eye appears to have continuous shades of gray, from essentially pure white to solid black and every intermediate shade of gray. But when you magnify this image, what you find is that the image is actually made up of a series of dots known as halftone dots. And the dots vary in size. In the light gray areas, the dots are very, very small, so that there's relatively little ink on the paper, and a lot of the white of the paper is showing through. In the very dark areas, the dots are so large that they actually overlap one another, leaving very little white of the paper showing through, so the image appears very dark. Generally, these halftone dots are so small that you can't actually see the individual dots with your eye. Therefore, when you look at the image, it appears to be a continuous tone grayscale image. But in fact, it's made up of these tiny solid black dots on white paper. If you look closely at a halftone, you'll find that the halftone dots are arranged in straight rows or lines. The halftone dots in this image near the bottom of the page are arranged into diagonal rows, and also you can see that there are rows going the other direction. The rows or lines of dots have a regular spacing, what we call the line screen frequency, or simply the line screen. There's a certain number of rows or lines of these halftone dots within a linear inch. So if we were to count the number of rows diagonally across in a linear inch, we would determine the line screen or the line screen frequency. And that frequency is expressed as a certain number of lines per inch. So a certain number of lines or rows of halftone dots within a linear inch. Within a given printed piece, the line screen never changes. You use the same line screen throughout the entire printed image. So the spacing of the dots always remains the same throughout the image. It's only the size of the dot that changes in order to create lighter or darker gray areas. So you see on this scale from pure white to pure black that pure white, of course, is the absence of any ink. It's simply allowing the white of the paper to show through. As you get into very light grays, you start to see some halftone dots surrounded by lots of white space. So if you viewed this with the naked eye at its normal size, this would appear to be a light gray. And in the middle, in a mid-tone gray, a 50% gray, the halftone dots are the same size as the white spaces between them. So you have 50% of the paper covered with ink and 50% of the paper just with the blank page, so that appears to the eye to be an intermediate or roughly 50% gray. And as you get into darker gray values, the dots increase to such a size that they occupy most of the paper, leaving just little bits of white space poking through. But the important thing to remember is that in any given piece, the frequency of these lines, or the spacing of these lines, remains consistent. Now sometimes you could print a certain job at a very low line screen where the rows of dots are spaced far apart, Or you could have a different print job where you choose to use a higher screen frequency, what we call a finer screen. And I think you can see that difference here. In the bottom right, the rows of dots, in this case there are vertical rows of dots and horizontal rows of dots, they're spaced pretty far apart, and the dots themselves are quite large, so that these would actually be visible to the naked eye. In a finer line screen, there are more rows or lines of dots, both in the horizontal and vertical dimension. We refer to this as a finer line screen. You can see that the finer line screen, the higher screen frequencies, capture a lot more detail than is possible with the low line screen. That's even more evident in this example. At the top we have a grayscale image that has been reproduced at a fairly fine line screen, 110 lines or rows of dots per inch, and you can see that it captures quite a bit of detail. At the bottom we have a very, very coarse line screen. There are only 20 lines or 20 rows of dots per linear inch. You can actually see the dots down here and see how these dots are arranged into these diagonal lines, and there are 20 of those dots, or 20 rows of dots in a linear inch. With a very coarse line screen like this, a lot of the subtle details are completely obliterated. So you might ask, well, why don't we always use a higher line screen? Why would you ever need to use a low line screen? It all comes down to the type of paper that you're using. The type of paper that the finished product is being printed on determines what kind of line screen you're going to use. And this is all because of a phenomenon called dot gain. When you print liquid ink onto paper, the ink soaks into the fibers of the paper and can actually spread so that the dots grow in size. That's what we call dot gain, where the individual halftone dots actually enlarge as they soak into the paper. A paper that is highly absorbent is going to experience lots of dot gain, so that the dots are going to grow significantly in size. What that means is that if you try to use a very fine line screen, the rows or lines of dots are spaced very closely together. The halftone dots are very likely to bleed into one another and create a really ugly, messy print job. So if you're printing on a highly absorbent paper like newsprint, you have to use relatively low line screens. And in the printing business, something in the range of 85 to 100 lines per inch is considered a fairly coarse line screen. If you take a look at images that are reproduced in a newspaper, if you look closely, you can actually see the individual halftone dots because the line screen is fairly coarse. On a better quality paper that is less absorbent, you can use a somewhat higher line screen. The rows of halftone dots can be spaced a little bit closer together. So on a better quality uncoated paper, you can print at 133 lines per inch. And an even better quality paper will have a light coating on it that prevents the ink from soaking into the fibers of the paper. And this can support even higher line screens like 150 lines per inch. And the best quality papers can support even finer line screens because they have absolutely no dot gain. The rows of halftone dots can be spaced very closely together. So using very high quality paper, you can print at 175 or 200 lines per inch, or I've seen halftones that go up even higher than that. Newspapers and anything else that's printed on newsprint is going to use those coarser line screens, 85 to 100 lines per inch. The vast majority of printed products are printed at either 133 or 150 lines per inch. So the vast majority of books, magazines, posters, brochures, almost everything that's printed is going to use that 133 or 150 line screen. So those are by far the most common line screens used for printing. The highest line screens, that 175, 200, or even higher, are reserved for very, very high quality print jobs where the customer is willing to pay for the highest quality paper and the finest quality printing. So these would be things like corporate annual reports or the very slick brochures that you get at a new car dealership, and art books where it's important to get the best quality printing of fine art in a coffee table book. So those higher line screens are reserved for very high quality print. Okay, so what does all of this have to do with the resolution of your raster image when you create an image in Photoshop or when you scan an image into your computer? You don't use the line screen itself as the resolution of your raster image. Those are actually two different concepts. The number of pixels per inch and the spacing of rows of halftone dots are two different concepts. They're not the same thing. But there is a mathematical relationship between them, and it's actually quite simple. If you know the line screen that's going to be used for printing your image, you simply double that number. And that is the resolution that you would use when creating your raster image in Photoshop or scanning or exporting from Illustrator or however you're creating your raster image. So to put it another way, the resolution of your raster image in pixels per inch should be twice whatever the line screen will be in lines per inch for printing the halftone image. The problem is that oftentimes you have no way of knowing what the line screen is going to be. You're working for a client, and even the client may not know what line screen they're going to use when they print the final image. The client is simply going to hand the job off to a printer. The printer will make the determination based on the type of paper that's being used. And so you may ask your client what line screen they're using, and they may not even be able to tell you. So you have to try to make an educated guess about what kind of line screen will be used for a print job, and therefore what resolution to use in creating your raster image. Well, since the vast majority of printed materials are printed either at 133 or 150 line screen, it's pretty safe to assume that most printed pieces can be created at 300 pixels per inch. In other words, twice the 150 line screen. So most of the time, you're pretty safe using a resolution of 300 pixels per inch for any image that's destined for print output. But be aware that there are some types of high-quality printing that are going to demand a higher line screen. So if you know that you're creating artwork that's going to be used in a corporate annual report, or a new car brochure, or an art book, then you may actually need to increase your resolution. So if something's being printed at 175 line screen, for example, you'd need to use a resolution of 350 pixels per inch in Photoshop. The Medical Illustration Sourcebook is a publication that prints at 175 line screen. And therefore, if you create an ad in the Medical Illustration Sourcebook, they recommend that you create your raster images at 350 pixels per inch. So you do occasionally come across images that are printed at these higher line screens. Okay, let's go back into Photoshop and look at some ways of modifying the physical dimensions and the resolution of an image. Let me open up an image that I exported from Illustrator just a few moments ago. And you see that same image of the eye and the cylindrical muscle fibers. Remember that this was originally a vector image created in Illustrator, but I have exported it as a raster image, and now we're looking at it in Adobe Photoshop. And you can see when I zoom in on this image that we can now see the individual pixels that make up this raster image. So the vector shapes from Illustrator have now been converted or translated into pixels. Let me show you some different techniques for modifying the size and resolution of this particular image. Go to the Image menu and choose Image Size. In here we have control over the width and height of the image as well as the resolution of the image in pixels per inch. I can simply change any one of these values. Notice when I change the width that the height also decreases proportionally. That's because I have this box checked that says Constrain Proportions. That means that as I change the width, the height changes proportionally, or vice versa. So it tries to maintain the same aspect ratio, the same ratio of height to width. If I were to uncheck that box, I could change the height and width independently of one another, but this is going to distort or deform the image. So I need to cancel that. And let's try that again. Make sure that we keep that constrained proportion box checked. I can also change the resolution of the image. I originally exported this image at 300 pixels per inch, which would be a good choice if this was going to be used for print output. But if I was going to use this in a web page, there'd be no reason to have so much resolution. It would simply be wasted information. So I could reduce this down to 72 pixels per inch, which makes the image significantly smaller. It actually retains the same height and width, but because we've reduced the total number of pixels, it appears to be much smaller on screen. Let's undo that. When I change either the physical size of the image or the resolution of the image, Photoshop has to recalculate the values of each pixel. So in other words, if I were to cut the resolution in half, Photoshop would take 2 pixels in the horizontal dimension and 2 pixels in the vertical dimension. This would actually be a square area consisting of a total of 4 pixels, basically a 2 by 2 grid. And it's going to compress those 4 pixels down into a single pixel as I cut the image resolution in half. Remember that when I cut the resolution in half, I'm cutting it in half in both the horizontal dimension and the vertical dimension. So I'm really cutting the total number of pixels down by a factor of 4. In order to calculate the value, the color of what that new pixel should be, Photoshop has to examine the value or the color of all 4 pixels and come up with some sort of intermediate value of that new pixel. Now, there are different mathematical algorithms that Photoshop can use in order to do that, and most people don't ever pay any attention to this. But down at the bottom of the image size dialog box is a little pop-up menu where you can choose the mathematical algorithm that Photoshop will use when it calculates the value of that brand new pixel. Fortunately, you don't have to really know very much about math in order to use this. You simply have to look at the little statements here in parentheses to know which algorithm is best. In this case, we are reducing the image. We are taking a 300 pixel per inch and reducing it down to 150 pixels. So the best choice is bicubic sharper, which is best for reduction. So if I'm decreasing the physical dimensions of the image, I'm making the image smaller, and Photoshop has to recalculate pixels. Or if I'm decreasing the resolution of the image, I'm still decreasing the total number of pixels, and Photoshop has to recalculate the value of each pixel. Now, alternatively, if I increase the size of the image, or if I increase the resolution, let's go up to, say, 450 pixels per inch, in this case, Photoshop still has to recalculate the value of new pixels. I'm creating new pixels that weren't there before, and Photoshop has to know how to calculate what the values should be for those new pixels. Anytime that I increase the total number of pixels in the image, either by increasing the size or increasing the resolution, then I would use bicubic smoother, which is going to give me the best results for enlarging the image. There's another very important item to notice here within the image size dialog box, and that's this box that says Resample Image. When I have this box checked, as it is right now, that means that any time I change the height or the width or the resolution, I'm actually changing the total number of pixels in the image. This is very, very important. In the 2 examples I've given you so far, we either decreased the resolution of the image or we increased the resolution of the image. In either case, we were changing the total number of pixels in the image. If you notice up at the top of the image size dialog box, it shows us the total number of pixels across, the total number of pixels in width of the image, as well as the height of the image in pixels. And whenever I change either the height or width or the resolution down here, you'll notice that those numbers change. So if I were to reduce the width down to, say, 2 inches, keep an eye on the top of the box where it says pixel dimensions. You'll see that the pixel dimensions decreased. Likewise, if I were to change the resolution, let me reduce that down to, say, 150 pixels per inch, the total pixel dimensions change again because I'm dramatically reducing the total number of pixels, both in width and in height of the image. However, if I uncheck this box, notice what happens up here in this little box that says Pixel Dimensions. The width and height of the image in pixels is fixed. The total number of pixels in the image, both in the horizontal and vertical dimensions, cannot change. So what that means is, if I decrease the width, the resolution increases proportionally. Alternatively, if I decrease the resolution, the physical height and width increase. So what's happening when I have this box unchecked is that we're keeping the total number of pixels in the image constant, but we're either spreading those pixels out over a larger area or compressing those pixels into a smaller area. This is very useful when you have an image, for example, that is physically very, very large but low resolution. You can reduce the physical dimensions of that image and simultaneously increase its resolution. So you could start out with, an 18 by 20 inch picture and reduce it down to, say, 9 by 10 and effectively double the resolution. Or another good use for this is if you scan something that's very, very small, physically very small, but scan it at a very, very high resolution, you can then decrease the resolution of the image, but the physical dimensions will increase proportionally. When I click OK, notice that the image doesn't change size at all. Even though I've changed the physical dimensions and I've changed the resolution, the total number of pixels in the image remains constant, so the image appears the same size on screen. Let me revert back to the original version of this image and show you a few other ways of modifying the image size. Under the Image menu is another option called Canvas Size. This lets you change the physical dimensions of the image, but without altering the resolution. Essentially, this lets you either crop in on the image and cut off part of the image, or it lets you add additional canvas, additional blank space around the image. So if I were to reduce this down to, say, 2 inches square and click OK, I get a warning that says that the new canvas size is smaller than the current canvas size. Some clipping will occur. And I proceed, and you can see that what we've done is we've simply cropped off part of the image, leaving only this 2 by 2 inch square in the middle. Let's undo that. Whenever I crop an image, I have the option of determining which part of the image is left and which part gets trimmed off. So let's say that I reduce the width down to 2 inches again, but I want to keep the entire eyeball on the left and simply crop off the right side of the image. With these little arrows here, I would click this left-hand box, which means it's going to keep the left-hand size of the image, and any trimming, any clipping is going to occur over at the right-hand side. Obviously, I cropped off a little bit too much, but it demonstrates the point. And I can also use the canvas size command to increase the size of the canvas to simply add some additional blank space around the outside. And you can see that that simply added additional white space around the outside of the image. There's a tool in the toolbar that does pretty much the same thing, the crop tool. With the crop tool, I can simply drag a selection around the image, and that box then gets these little handles at the corner that allow me to drag in as close to the image as I want, or perhaps to even crop off part of the image. If I drag the right-hand side way over, I can trim off those muscle fibers, leaving just the eyeball behind. Once you've positioned the crop tool exactly where you want it, simply hit the return key and you've cropped the image. You can also use the crop tool to increase the size of an image. If I enlarge the window so that the window is bigger than the image, I can drag the crop tool around the entire image. And once I've done that, I can then grab those little handles at the corners and I can make the image even bigger than it was originally. And this is going to add additional canvas size around the outside of the image. Again, just hit the return key and you can see how we've added some additional white space around the outside of the image. You can also specify a precise height and width for the image, as well as a specific resolution for the image. So I can say, after cropping this image, it will be exactly 6 inches wide by 3 inches tall at 150 pixels per inch. When I drag the crop tool now, you may be able to tell that the rectangle is fixed, has certain fixed proportions, because it's following that those proportions that I entered, maintaining that same aspect ratio. Let me pull this down a little bit, and the image isn't going to quite fit in there, but that's okay. Or if I wanted to, I could always increase this a little bit more, which is going to obviously crop off the top and bottom, but add a little bit of extra image to the left and right. And now I hit return, and the image that I have now should follow these exact dimensions: 6 inches in width, 3 inches in height, 150 pixels per inch. If I go into the image size dialog box, I can confirm that the new image is exactly that size. So that's it for understanding image size, how to determine the correct image size for your artwork, how to modify the image size, and also understanding this very important concept of resolution. So hopefully you will remember that if you are creating an image that is designed to be used exclusively on the computer, a web page, a PowerPoint presentation, anything else that will be viewed on the computer, 72 pixels per inch is adequate resolution. On the other hand, if you're creating something for print output, you have to think about what the line screen is that's going to be used for printing that image, and the resolution of your image should be twice the line screen. Before I finish, let me give you just one more tip about image size and image resolution. Even if your client tells you exactly what size image they need, the exact physical dimensions, and the client tells you exactly what the resolution of the image should be in pixels per inch, frequently it's a good idea to create your image quite a bit larger than what you actually need. Here's why. First of all, there is a pretty good possibility that that client is going to come back to you at some later date and ask for another copy of the image at a different size. This happens to me all the time. You have a client who calls you up and says, I need an illustration for a web page. It needs to be 640 pixels wide by 480 pixels tall, and since it's for the web, obviously it only needs to be 72 pixels per inch. So you create the image at that exact size, and then 6 months later the client calls you back and says, oh, we loved that image, now we want to use it on the cover of our annual report. And so now you need to create that exact same image at 8.5 by 11 inches, and since it's a corporate annual report, it will probably be printed at a very high line screen, so the resolution may have to be 350 or even 400 pixels per inch. There's no way you could possibly take that small image that was created for the web and blow it up to that larger size. You'll be forced to completely recreate the image from scratch. On the other hand, if you had created the image at a very large size to begin with, you could always send your client the smaller version that they need. Never send the client anything bigger than what they need. There's no reason to do that. So you could send them a copy at the smaller size. Meanwhile, you would keep the big version for yourself, and if the client ever calls you back and says, we need to use this at a bigger size, aha, you've already got it done. Save yourself a lot of time. Another reason to create the image at a larger size is that it's a good idea to retain the copyright to your artwork. Many clients will try to get you to sell them the copyright, but if possible, it's a good idea to license only limited rights to the client so that they only get to use the image for certain very limited things, and you actually retain the rights to reuse that image, and in particular the right to relicense or resell that image to other clients in the future. Therefore, if you have the artwork created at a larger size, you'll be prepared if some other client in the future wants to use that image in some different medium, perhaps at a larger size. So by creating artwork at a larger size than what you really need, you are prepared either to provide a larger version of that image to the original client, or if you keep your copyright, to license that image to additional clients in the future. We'll talk a lot more about copyright and licensing in the future, but that's just a little heads up about a couple of reasons why it's a good idea to actually create artwork bigger than you need it initially.